In this class, we'll be going through nomenclature, preparation, and some physical properties of carboxylic acids. So, first we'll go through nomenclature, both common names as well as IUPAC's names. Of carboxylic acids. So carboxylic acids are amongst the earliest organic compounds to be isolated from nature. Hence, a large number of them are known by their common names. Common names end with common names of carboxylic acids ends with suffix ic, and have been derived from their Latin or Greek names of their natural sources. Names of their natural sources. For example, formic acid, which is HCOOH, is first obtained from red ants. And in Latin, formica means ants, and hence the common name of this HCOOH is formic acid. You see that there is a suffix, it ends with suffix ic. Same with acetic acid. Acetic acid, which is obtained from vinegar. Its formula is CH3COOH. In Latin, vinegar is named as acetum. For example, butyric acid, its formula is CH3 is obtained from rancid butter. And in Latin, butyrum means butter. So these are few common names. If you go back IUPAC nomenclature, so aliphatic carboxylic acids are named by replacing E in the corresponding alkane with oic acid. For example, formic acid, which is HCOOH, Its corresponding alkane is methane. Hence, formic acid is named methanoic acid. Acetic acid, which CH3COOH. Its corresponding alkane is ethane, and henceforth acetic acid is named ethanoic acid. Similarly, the corresponding alkane of this carboxylic acid is propane, and hence this carboxylic acid is named propanoic acid. In numbering the carbon chain, the carboxylic carbon is numbered 1. So, while numbering carbon chain, carboxyl group is numbered 1. For example, this is numbered starting from carboxylic group is numbered 1, and the longer chain is followed, and this is named as 2-methyl pentanoic acid. For naming compounds, containing more than one carboxylic group, so more than one carboxylic group, the ending E of the corresponding alkane is retained. The corresponding alkane is retained. Further, the number of carboxyl groups are indicated by adding the multiplicative prefix di, tri, etc. to the term oic acid. So to this, the prefix di, tri based on the number of carboxylic group. For example, oxalic acid. With formula C2O4H2. So the corresponding alkane is ethane. So this is named as ethane. E is retained and dioic acid. Malonic acid with COH. The corresponding alkane is propane. So this will simply be named as propane dioic acid. So it would help you if you could remember some of these dioic acids. Succinic acid. With formula so the corresponding alkane is butane. And this is butane dioic acid. So similarly, glutaric acid. Will be named as pentane dioic acid. And adipic acid with formula COH. So this will be hexane dioic acid. The position of the carboxylic groups is indicated by Arabic number. Before the multiplicative prefix. So for example, this will be named as propane. One, two, three, tricarboxylic acid. So few other aromatic carboxylic acids. Let us go over their names. So this will be benzoic acid, benzene carboxylic acid, or benzoic acid. This is going to be phenyl ethanoic acid. So this is going to be benzene 1,2-dicarboxylic acid. This should suffice for the nomenclature of carboxylic acids. So what will be its structure? So in carboxylic acids, bonds to the carbonyl carbon, carboxylic carbon. So the bonds to this carboxylic carbon lie in one single plane. So one plane, all the bonds are in one plane, and they are separated by about 120 degrees. The carboxylic carbon is less electrophilic than carbonyl carbon. Because of the possible resonance here. So because of this resonance that is possible here, the carboxylic carbon is less electrophilic than carbonyl carbon. So now let us go over preparation of carboxylic acids.